Hello?
Hey, Roger, that's better.
Okay. I did not open my mic.
How are you?
Sorry. Yeah, fine. We have many people attended this video conference. Everybody very interested.
We maybe you can let me know when we can start and when you've got everybody who's due to attend.
Yeah, we can start. We can start on time now.
Okay, excellent. All right. Allow me just to share my screen, make sure everybody can see. So can you see the presentation, Roger?
Yes, we can see. And
Excellent.
Michael, we will shut down our video. Is okay?
No problems at all.
Okay. Harry, 请关掉视讯哦。Okay.
Okay.
Okay.
Good. All right. Well, good morning, everybody, and thank you for joining me today on what is the first of a three-part training program around Invinity Energy Systems, our products, and how we go to market. Just by way of, I suppose, if there is any questions, please put your hand up in the raise function, or if you want to type your questions into the chat, that's fine, and we can address them at the end. But if you have any questions, I want this to be an interactive session. So if you have any questions, please just raise your hand, and we'll address them as they come up.
Okay, thank you.
Okay. Okay, so today's session is really a commercial overview. So today we're going to address the core Invinity story, what our base messaging is that we use globally in taking Invinity and our product to market, how we position vanadium flow batteries versus our basic competitors. And then future sessions will delve more into the technical aspects, the core technology. And then the third session we will hold in a few weeks will be how we go about building a proposal and working basically from working our way through the quote to cash process. Today we'll delve into who is Invinity. We'll give you an overview of Invinity as a company, our operations, our capabilities, and so forth. We'll talk about why utilising a vanadium flow battery, what's the value proposition, and put some substance behind those value propositions, and then also look at the competitive environment, how vanadium flow batteries compare with other technologies available in the market, both long duration and short duration. And then finally close out on opportunity assessment and qualification. And then we can address any questions that you might have through the session as well. So very briefly, who is Invinity Energy Systems? We are a UK listed company and a global leader in the development and manufacture of vanadium flow batteries. The product's designed and manufactured in the UK, US, and Canada, and obviously now with a partnership with Evergyr in Taiwan. We were established in 2020 after a merger between two existing flow battery manufacturers, Redtea, based out of the United Kingdom, and Avalon Battery, based out of the UK and Canada. That merger brought together the skills of both companies. Avalon Battery were a very engineering-focused business. Redtea were a very sales and business development-focused company, and it brought those strengths together to form Invinity. We manufacture a standardized product, and this is the core. This is one of the core messages behind Invinity. Previously, a lot of the vanadium flow battery product that was available in the market was customized on a project-by-project basis. This made it very difficult to maintain quality, and it meant that it was very expensive. Our aim is to be able to build a standardized product that is of high quality, can be delivered on time, and maintains a standard product performance across a broad portfolio of projects. To date, we've delivered more than 1,200 flow batteries into the market, and we have one of the largest deployed fleets globally. We currently operate the largest flow battery solutions in the United Kingdom, Australia, and North America, and have over 82 projects deployed around the world and 160 megawatt hours of operating systems. Currently, we're at 152 employees globally. Myself, I am the regional director for the APAC region based out of Melbourne. But we also have operations all around the world. We hold 81 patents, and we've got a combined 15 years worth of R&D and investment. Globally, Invinity has a global presence across most countries and most regions. We have manufacturing in Vancouver, Canada, where we also have an R&D and design team. We have sales office in San Francisco. We have a London sales office. We have, again, design, R&D and manufacturing based in Bathgate in Scotland, which is just south of Edinburgh. We have a manufacturing partner in Suzhou in China, myself, a sales office based in Melbourne, Australia, and then obviously partners such as Everdura based in Taiwan and around the world. So as an OEM or an original equipment manufacturer of vanadium flow batteries, we have an established and proven supply chain manufacturing process and delivery strategy. We to date have manufactured over 2,200 individual cell stacks alone and have reached the point where we have a quality product that passes first test 99% of the time. We've delivered as I said, over 1,200 battery modules around the world, and we are fully ISO certified, modular architecture, and safe by design. And these points are absolutely critical in terms of when you're talking to your customer about the Invinity product, is that it is not a new product, it's not an emerging product. We have been building these products for a long time. We've got a number of products out in the market, and they are proven, and they are safe, and they work. In terms of looking at who our customers to date have been, we deal with a broad spectrum of customers around the world. In the front of meter market for utility scale projects, we deal with the power utilities, developers, the transmission and distribution network operators. In front of meter energy storage solutions that can provide frequency services, balancing and wholesale market trading. We have a number of large commercial or industrial customers who are utilising our batteries for carbon offset, energy cost reductions, peak power shaving and so forth. And then we're also seeing a number of applications in the microgrid sector where we are providing resiliency and 24/7 renewable power, generally in hybrid applications where there is co-located solar PV, but then also maybe diesel power sources as well. Our product today, our current product is the VS3. I'm not going to dive too much into the technical. That will be the next training session, but this is our currently formatted product. We are developing a new product which will replace the VS3 sometime next year, called the Mistral, And again, in our technical sessions, we'll talk about both of those products. But this is the product we bring to market at the moment. It's a 78 kilowatt, 230 kilowatt hour energy storage system in a 20-foot standardized shipping container. And we'll talk about some of the features and the benefits of this product a little bit later through the presentation. Something that's very important for your customers is obviously bankability. You'll be dealing with developers, utilities, government, who want to know that you're supplying and dealing with a company that is secure and a product that is of quality and proven performance. The global consulting firm DNV last year conducted an audit and published a bankability report in regards to Invinity's VS3 vanadium flow battery. The statement from DNV is that they consider the proven ability of the VS3 to provide operational flexibility, ease of installation, modularity, to be a leading among flow battery suppliers and comparative with lithium-ion battery suppliers for applications over 100 kilowatts of power. This is really important that we've had that it's not just Invinity saying to you, this product works, it's fantastic. We're also saying to you,
Microsoft Teams,
this product works, and here is an independent body who has done a complete analysis of our product and has been willing to publish a report that verifies everything that we say about our quality, about the product performance, and about the maturity of the technology that we're bringing to market. This report's Roger. I'm not sure, but do you have a copy of this report, Roger, and available?
This is what we saw first time.
Yeah.
Okay, so this already proved by DNV.
Yep.
For
sorry, for DNV for?
This already approved in last year?
Yes, last year. So this is for VS3, and for the new product, Mistral, Roger, we will undertake a similar report once we've got manufacturing and plant in operation.
Okay.
So we will look at doing a similar report for Mistral sometime into next year.
Okay, thank you.
Okay. The company is globally certified both ISO and then product certifications under UL and CE. We hold ISO certifications for quality, for environmental, and for OH&S. We're the only flow battery company to hold all of these certifications currently. We can make these certification reports available to you. We've just completed an audit on all our ISO certifications and have passed again. So we're able to provide for any of your customers copies of these reports if they want evidence of our ISO certification. All of our product is also globally certified to appropriate standards, so UL, CE, and ICE standards. Not sure what standards do you use in Taiwan, Roger?
Taiwan is CNS.
Follow IEC development.
Basically, follow most of our contents from IEC.
I see. So it's very, very similar to Australia.
Yes.
So we're compliant with those, and obviously with Mistral, we will ensure that the same certifications pass through as well.
From this year, August 22nd,
Mm-hmm.
The government requested all the bidding related with the Taipower is required GNS standard.
GNS standard?
CNS.
CNS standard.
CNS.
Yep.
Chinese C national.
Oh, the Chinese standard.
Yes.
And sort of just to show where we've come from and where we're heading as a company. In 2018, we were building these AFB2 very small units that were being mounted as an integrated product as part of PV systems. In 2021, we moved to the VS3 after the merger between Red T and Avalon Battery, and brought the product into a containerized and more scalable product. And then from the middle of this year onwards, we will be working with our new platform, which is codenamed Mistral, which will again improve both the levelized cost of the system, but will also give us a greater scalability to be able to tackle projects in the gigawatt scale. That product is in development, and again, in the technical training session, we will be able to talk to that and explain the differences between the current VS3 product and Mistral, and explain the timelines for its availability. Is there any questions as yet?
Yeah, so far there is no question.
So far, so good.
Yes.
Okay, so why utilize a vanadium flow battery? What are the advantages of a vanadium flow battery? How do we present a product to market, and how does it stack up against our competitors? So first of all, these are the core value propositions that we take to customers when we're presenting vanadium flow batteries to them. And there's 6 key points here. Safety, or the product is safer. It cannot have a thermal runaway, so therefore there is no fire risk. Our electrolyte is predominantly made of water. It is exceedingly safe, and we have containment systems that contain any leakage. We have a product that is a longer life than lithium batteries. It can operate up to 25 years with minimal major maintenance. It's sustainable. We have no conflict materials like cobalt contained in our products. All of the components and the electrolyte itself are easily recyclable. At a certain scale, our product has a superior levelized cost of storage in comparison to lithium and other long duration technologies. We're proven. We have product in the field and operating. And then, as I've said before, we have a standardized product, which means we can set high standards for quality and performance through consistency and consistent of component manufacture. So if we dive into each of those points a little more detail, let's talk about safety first. So this is the safety standards that would be used if you were shipping these products on a truck around the world. This is also contain markings on the container. So as you can see, for a lithium battery, for example, you have a high rating of chemical hazard. It's highly flammable, it's highly reactive, it contains toxic compounds, and it has high corrosion risks. So if you look at these rating numbers, 0 to 4 indicates the level of hazard. So example, for flammability, it's a level 3, which means it's a very high risk of, level 3, which means it's a high risk of fire. High reactivity, level 3. High toxic compounds, level 3. And high corrosion risks, level 3. The W with the line through it there also indicates that it is highly reactive with water, which is a risk that needs to be identified for fire services in case they have a lithium-ion battery fire. In comparison to our VFB, the only true risk we have is the corrosion risk from the electrolyte, and that's obviously because the electrolyte has sulfuric acid in it, and sulfuric acid is a mild corrosive. There are no other risks from thermal runaway, limitation of storage, fire risks, or reactive materials in our battery. So it is inherently recognised as being a safer product than lithium. The low flammability comes from the UL standard 9540A. This is the test for thermal runaway. This is accepted globally as the test for large-scale fire tests for installation of large energy storage systems. It tests material for the likelihood of thermal runaway and then determines the site safety requirements for the battery. So whether you have to have distances between batteries to prevent fire spreading, whether you have to have containment methods for fire in case it occurs. The Invinity VFB electrolyte is non-flammable, with a zero thermal runaway potential. This is absolutely critical, especially if you're talking about batteries being installed close to residential areas. There is no significant safety disadvantages with our battery, and therefore we can be placed in locations where a lithium battery may be considered an unsafe application. It also means that in deploying a vanadium flow battery, we don't require fire suppression equipment or fire detection equipment in the same way that a lithium-ion battery does. And many lithium-ion batteries will have gas fire suppression systems built into them with a fire detection and alarm system to discharge the gas in the case of a fire. In Australia, for example, fire risk with lithium batteries is such a major concern. The batteries have to be spaced differently, meaning that they take up more land. The batteries have to have fire detection systems, as I mentioned earlier, but then battery sites also have to have a significant amount of water on site to be able to suppress fires if they occur. This all adds to the cost and the complexity of deployment. Another significant advantage with the VFBs is low noise. Again, when installing batteries close to residential areas or in regional areas where sound travels, lithium batteries, for example, have complex cooling systems. Some have air conditioning systems to manage heat and to keep the batteries safe and cool and safe. This means that they can be quite noisy in high temperature locations. We've conducted noise testing on the Invinity VS3 and have passed the standards in the UK for noise operating conditions, and it means that we can position our batteries to operate normally in areas where lithium batteries would normally be considered too noisy for that application. And we will undertake the same type of noise tests for the Mistral product when it comes out as well, and be able to provide that to your customers if needed. Critically, if you look at the noise level, the highest recorded noise level is 78.5 decibels. PPE, safety equipment, is required when the noise is greater than 85 decibels, which means our battery is operating at a noise level which requires no PPE when you're on site and interacting with the battery.
Michael?
Yes?
Can you back to last page, about noise?
Yes, this one? Yep.
Yes, and the number 3, you indicate PPE is required when noise is bigger than 85 dB.
Correct.
So this PPE is one kind of standard or materials?
It's personal protective equipment, Roger. So it would be it would be hearing protection. So some form of earplug or over-ear mufflers to reduce sound.
Okay.
There you go.
Okay, thank you.
Okay. One of the other points that was raised in our key values is that we have a proven product. It's deployed, it's operational, and we have repeatable technology. This is a list of just some of the projects we have around the world, and as you can see, we have a significant amount of equipment operating in different applications across North America, the UK, Asia, and Australia. These are operational, ongoing, long-term assets working in different environments, but they prove that we are not a pilot product or a conceptual product. We are a commercialized, repeatable solution that can be taken to the market. And that equates to your customers, that equates to less risk for them because they're dealing with a product that's been deployed. We know what happens when it's in the field. We know how to service it. We know how to operate it. And we know how it will perform. And that gives peace of mind to your customers and reduces their perception of risk of moving into it and utilising a technology that, like vanadium flow batteries, that they may not have used before. If we look at an example project, this project went fully operational in late 2023. This is the Spencer Energy site in Australia. So it's an 8 megawatt hour system, 41 VS3 batteries attached to a 6 megawatt peak PV plant. This, on an annualized basis, this site should supply around about 6 gigawatts of energy to the Australian national energy market. It's on a site in South Australia and is a DC coupled system using SMA DC coupling equipment and PCS.
Oh, Michael?
So, yeah. Yes, Roger.
Can you back to 19 page? Last page.
That one?
Yes, and the button side, button number 3, Amerisco. These are only 72 kilowatt hour battery capacity. Do you see that?
Sorry, which ones?
19 page 19.
Page 19. So, yep.
The
Americaso.
Battery capacity is only 72 kilowatt hour.
Yes, it's a very, very. It's an older system, Roger. It was deployed in 2020 and it used the older Avalon battery system.
But even in 2020s.
Yep.
2.5对啊。
Okay.
So the 3 systems in 2020 were older systems from deployed by Avalon or Red T.
Mm-hmm.
So they weren't using the current VS3, but again, very similar technology in terms of when we stepped up to the VS3.
Okay, so did you may receive my email yesterday? So
yes.
Later on, not now, but later on we will discuss with you about small module application.
Yeah.
Maybe
definitely.
Maybe like this.
That's fine, Roger. Yeah, no, I did see that, and Colin and I have had an initial discussion about it.
Yes. Okay.
Good. Again, just another example of a deployed project, and we can provide you with case studies and examples of deployed product to provide to your customers. This is the Capice Lake Solar and Storage Facility in Alberta in Canada. Again, 8.4 megawatt hour, 38 VS3s attached to a 21 megawatt PV peak plant. This again is operational. We will start seeing data from this site and see the trading data for it. So I suppose the message here is this is just two examples of operational sites that we have utilizing our technology. We have more sites, we have more projects, and we can provide you with case studies to give your customers peace of mind when you're talking to them about our product, to prove that it is a commercialized and serially produced, readily available product that is operating in the market as we speak. I think the other thing that's really important is one particular component, which is the cell stack. Again, without getting into the technical details, the cell stack is the heart and body of a vanadium flow battery, and we have worked very hard to perfect the S4 stack component to the point that with the new Mistral product, rather than developing a new stack, we're using exactly the same stack as has been proven in the VS3 in Mistral. That's how good and how well this component performs. We've done a lot of work around sealing technology to prevent leaks, scaling up the manufacturing process and simplifying the manufacturing process to produce a product that is of quality time and time again. We've worked on cost optimization, and we continue to look at how we can continue to improve this product. But again, there is over 2,200 of these individual stacks out in the market as part of our deployed systems, and with a very low failure rate and very high first pass test rate. This is absolutely critical in proving to your customers again that our technology is mature and can deliver positive results for them on an ongoing basis. So economics is always a challenging discussion to have with developers, especially if I look at the Australian market. CapEx or the capital cost of the battery has been always the first part of their decision-making process. However, the reality is that if we look at high throughput applications, so applications where you are potentially cycling the battery more than once a day, say twice a day in this example, over the life of the product, a vanadium flow battery will provide significantly more energy to market and therefore revenue than its equivalent lithium product. This happens because, one, we have ultra low capacity degradation over our life. A lithium battery degrades fairly aggressively from years 5 to 10 and 10 to 15, where a vanadium flow battery has a much, much lower degradation rate and therefore maintains peak operating volumes for a much longer period of time. This is because the electrolyte itself doesn't degrade, and that the degradation that does occurs in the membranes of the cell stack. The other important point here is high throughput applications are absolutely ideal for our product. Lithium batteries are generally stuck with a single cycle a day. Otherwise, you accelerate degradation and potentially void warranty. Vanadium flow batteries can operate either on 2 full cycles a day or multiple short cycles to be a much more flexible product to deliver much significantly better cost and revenue outcomes for your customers. We also, have developed metrics to ensure that we can identify any potential faults or failures with the battery and address those before they become a problem, therefore meaning that the battery is much more maintainable and that our battery availability and its overall performance is more consistent than having to have a battery that would fail and require a responsive service, a reactive service, rather than a preventative maintenance program. finally, sustainability. And this is obviously a concern for a lot of developers who, certainly if I look at the Australian market, a lot of the renewable assets that are being deployed in Australia are being deployed on farmland or disused farmland. That land is generally leased from a landowner and must be returned back to its original state at the end of life of the plant. The beauty of a vanadium flow battery is that we are upwards of 97% recyclable. The battery module itself is a combination of steel, plastics, power electronic components, cell stack, and electrolyte. The steel and plastics can be recycled through conventional recycling methods. The power electronics can be processed alongside other consumer electronics recycling processes. And the stacks can potentially be recovered and reused into future systems with some slight change, with some replacement of the membranes. The electrolyte, which can make up from 25 to 40% of the total cost of a system, is 95% recoverable. You can reuse that electrolyte in a new battery at the end of the original battery's life, or you can process that vanadium out of the electrolyte and then trade that vanadium on the market. This means that we have high recyclable rates of our product, but also that the electrolyte itself has a net embedded value because it can either be traded or it can be reused for as long as you like. This gives us a very interesting proposition to your customers, because a lithium battery, which really doesn't have any value at the end of its life, or only has a very small partial value to be used as a second-hand battery, it's also got a lot of challenges when it comes to recycling. Because of the recyclability of the electrolyte, you not only have a high residual value in that electrolyte and the asset at the end of life, but you also have a much simpler process for recycling the asset and restoring site location back to original. Because there's no products or byproducts within the battery modules, what we also see is that they don't require any special disposal during decommissioning, and therefore the costs of decommissioning can generally be offset by the pricing that you can get for the scrap materials in the market, and by the value of the electrolyte if you trade that off. So therefore, you could almost have a zero cost disposal cost model for a flow battery at the end of life. Okay. Any questions there at all?
Any questions? So far, so good.
I can't be doing that good a job, Roger.
Excellent.
Okay, so let's have a look at flow batteries versus our competitors, and what we identify as the key advantages and why we think vanadium flow batteries is the best, not only long duration technology, but also the best energy storage technology. So this table is pretty simple and straightforward. It shows vanadium flow batteries versus lithium ion, zinc bromide flow, which is considered a hybrid flow battery, iron flow batteries, and organic flow batteries. Without going into the details of all of these other flow technologies, they all use a different type of chemical electrolyte to create the energy storage and the electrochemical process. They may use slightly different stack technologies as well to initiate that electrochemical reaction, but fundamentally they all work on a similar sort of principle in general. So if we look at all of these other technologies, there are, vanadium flow is the only commercially available mature product that has an unlimited cycle count. This is a very important message for your customers. A lithium battery has a limited cycle count of 6,000 to 8,000 cycles. Now that might seem like a lot, but that equates to a cycle a day over a 10 to potentially 12-year period. If you cycle a lithium-ion battery more than the determined cycle count, you will either lose or you reduce the amount of warranty that you will have. The Invinity vanadium flow battery warranty has nothing to do with cycling. It is purely a manufacturer's and quality-based warranty. So therefore, the owners of and operators of one of our batteries can cycle it as much as they like, without any concerns for implications around warranty or battery performance. As a matter of fact, we like high throughput applications. We like high cycle applications because that's when our product performs best. Warranty, obviously from a fire safety, we've spoken about this. Our product is non-flammable. That is fairly consistent with most flow batteries because we all use a liquid-based or water-based electrolyte. Lithium-ion fine safety is limited, and obviously it requires detection and suppression equipment on site to manage fire risk, which is not required on any of the other products. We have a superior warranty lifespan. We can provide extended warranties with customers up to 25 years, and those extended warranties can include spare parts warranties as well as performance-based warranties. Lithium-ion batteries generally will provide a 5 to 10-year warranty as standard. They will, and I have seen extended warranties up to 15 years, but at 15 years, they require major maintenance to move through to a lifespan of 25. Most of the other technologies we see in the flow battery space are working on a lifespan of 10 to 20 years, but will only offer a warranty over that period of maybe half of that. And then from a technology maturity point of view, obviously lithium is the most mature energy storage product in the market, and that's simply because it's in our laptops, it's in our phones, it's in our cars now. And so it's a highly established and mature technology. We see vanadium flow, and we believe Invinity's vanadium flow has now reached a similar level of maturity in the market. And certainly when we look at our competitors in the flow battery space, we believe that we are significantly more mature as a product than what they are. If we really focus down on lithium, because that's our competitor. That's who most of the batteries in the world are being deployed at the moment are a lithium product. So therefore, that is who we need to compete with. We believe we provide capabilities beyond that which is applicable to lithium. They're ideal for, again, high throughput, beyond one cycle a day, or flexible discharge durations beyond 4 hours. If you've got a client that is asking you, that wants you to put a price forward for a 1 hour battery, we're probably not going to succeed. It's not the product performance capabilities of a flow battery in the 1 hour market. That is a market that requires high power density and lower costs. So generally that is a lithium market. We try to position ourselves, and certainly in Australia, we are focusing on the market of 4 hours to 4 to 12 hours as being where we are optimized as a product and can be competitive against all other solutions. Obviously, planning approvals in new areas, we're concerned around noise and fire risk. We've spoken about that. Asset life, interestingly, asset life is comparable with co-located assets such as PV. So again, in Australia, we see a lot of batteries being deployed to support large-scale solar. Those solar plants have a life of 25 to 30 years. So why would you not deploy a battery that has a similar life cycle to what the PV asset or the generation asset has? You can't do that with lithium. You would have to repower the lithium or replace the lithium system halfway through the life cycle of the PV. And again, stemming back to warranty, we have certainty and simplicity in our warranty because there's no connection between the warranty and cycling, which means you can operate the battery in any manner which maximises your revenue without being concerned about losing or having a reduced warranty coverage. Other critical points, Invinity flow batteries have a stable capacity and efficiency, and it's due to its reduced degradation, where capacity and efficiency degrade with lithium-ion batteries over time. Both batteries can do sub-second response time, and therefore we can operate in the grid support or frequency markets that exist around the world. We've spoken about the safety, and we've spoken about the warranty already. And obviously, from a manufacturing point of view, Invinity, we're manufacturing out of the UK, Canada, with a partner in China doing some of the heavy engineering. Obviously, we're in discussions around manufacturing in Taiwan with yourselves. Most of the product for lithium is coming out of China, and that is not a major problem for us in Australia, but certainly in some countries like the US and the UK, where barriers are being put up for and trade levies are being put in place. Having a flexible manufacturing base that can exist outside of China is also important, so that we don't run into restrictions in accessing market due to local market rules and regulations. Okay, no questions? Keep going, Roger.
Yeah, it's okay.
Good. Okay. Capabilities and applications. So we spoke before about focusing on certain applications. This graph's pretty straightforward in that it shows that the space between the grey line, between the 200 and the 4, and the black line running from 800 to 12 is essentially where we see vanadium flow batteries have a significant advantage over our competitors. This is where we can operate in areas such as solar dispatch, providing overnight renewables, microgrid resilience, wind tidal dispatch, operating reserves or grid support functions. Below that, in this area here, we see that it is difficult to compete against lithium, because these markets generally require product that is high energy density, therefore can inject a lot of power and energy into the market very, very quickly over a short period of time, and is also a very cost-sensitive market. So therefore, the capex of a lithium battery versus a vanadium flow battery becomes advantageous to lithium in this particular space. So again, when you're looking at projects and when you're talking to customers and looking for where your opportunities lie, it's really important to identify that there are two key areas that are important. How many cycles a year do they want to have? And what type of cycle duration are they looking for? We can compete anywhere in this space. And for example, again, referring to the Australian market, a lot of the batteries now in the Australian market are tending towards being 4-hour batteries, as the volume of batteries in this 1 to 2 hour space have now flooded the frequency markets, and therefore duration and energy into the grid has become more important. And we're seeing that 4 hours and very soon 8-hour batteries will be the core markets in Australia. We're also seeing that that's emerging in the UK and certainly in certain markets in the US. So very important to target high throughput applications so that you can talk about cycle without limitation, age, economically scaling to 8 hours plus, and then also looking at the type of application in terms of, does it, delivering renewable power on demand, trading at capacity, bottlenecks on the grid, backing up critical infrastructure. Again, I can't say this enough. Our batteries are meant for high throughput and wide flexibility. And that is if we can focus on this section of the market, if we can focus on these types of opportunities, you will have a higher sales and success rate. Another interesting application here, and again, this is looking at this running 2 cycles a day or multiple cycles a day, is how can you stack cycles with our battery for maximum benefit? So this could be an application in both the front of meter and the behind the meter space, where you have, for example, solar PV generation on site. You add a vanadium flow battery, and what you get is these two discharge cycles. You have a charge cycle in the middle of the day from the solar, and then a discharge cycle in the evening using the battery. And then you charge in the evening again from low cost electricity off the grid, so that you can have a discharge cycle in the morning peak before topping the battery up again. This is an ideal application in the industrial sector, where you have manufacturing plants running nighttime shifts who want to be able to enact some form of peak energy shaving through utilising PV and the battery to take out peak loads and therefore reduce their overall costs of energy. It's also very good if in the microgrid space, where you may have solar PV on a microgrid environment, and again, you need to provide energy in the evening when there's peak loads, first thing in the morning when they're peak loads, but then have a lower demand curve during the day because people are at work, and also because you've got PV topping up and providing generation as well. The beauty of this cycle is that this type of profile, this type of application, is that it allows, from a front of meter application perspective, to play in all different types of revenue markets. So you can do arbitrage in the evening when you've charged your battery off your low cost solar, and you can take advantage of high prices for electricity in the evening when there's high demand. You charge again at night off the low cost energy later in the evening, but then can take advantage of, say, frequency markets or another peak in pricing in the morning through using that low cost energy that you've brought in. And so you can have arbitrage and frequency plays off the same site.
Michael?
Yep. Yes, Roger.
Yeah, this page. Hold on, please.
Yep, that one there.
同时可以充放，对，有，这只有 DC couple 可以这样做而已。这边是同时充跟放，对，这边也是同时充跟放，所以这个状况是跟太阳能边充边放的时候，一边充一边放，这只有 DC couple 可以做到 ，AC couple 可以做到这样子吗？对，只是说应该这是 DC couple、AC couple 有没有机会
？Okay. Hello, Michael.
Yeah.
As for this chart mentioned, from AM 4 o'clock to the 10 o'clock.
Mm-hmm.
This is during charge and discharge in the same time.
There can be a little bit of overlap. It depends how we configure the system and how many arrays of batteries you have. You can discharge the system on a string or array basis. So you can discharge one string fully, then start to charge that string, and while you're discharging another string and so forth. It really depends on the system configuration.
So this system configuration is designed by functional requirement.
Correct.
And this is only for DC couple, or also for DC couple and AC couple?
You could do the same thing with AC coupled. Obviously, this depends on having co-located generation, so wind or solar, to provide the low cost charge cycle in the middle of the day. However, depending on what the cost profiles of electricity is during the day, you could do this as an AC coupled profile with charge from grid. It would just be a matter of identifying the lowest possible cost of electricity to enact the charge cycle, and then identify the energy peak so that you could discharge at a margin.
Okay, hold on, please.
Yeah.
Oh. Hello, Michael.
Yeah. Yes, Roger.
As you mentioned, it can be designed by different stream application for charging and discharge.
Yes.
So it's also on the different PCS which connected to the different stream. Is right?
Absolutely, it will depend on the capability. Some of this depends on the capability of the PCS. Some DC coupled PCSs can't do charge from grid. Where I know, for example, SMA PCSs can do charge from grid in a DC coupled application. But it very much depends on the power electronics, the site, the net, how the individual market functions. There's variables. This would need to be designed on a project by project basis to get this profile working ideally. But again, that's what your EMS is for, and that's also if your client is using a bidding platform to bid to the network, to that bidding platform would also support this type of function.
Okay, hold on, please. Okay. 所以刚才说的
EPCS 就没办法这样做了啊。你说海洋能要测试那个，
那只有一台而已。
是啊，
你不能同时充放啊。
这跟我们之前概念是一样啊，就是一台 standby 是在充，一台 standby 是放，然后充饱以后再 standby 切换过来。
对，那你还是独立的。
是啊，那没啥。
那你要足够的资本去做两套系统。
对，包括像 data center 的部分也有光储的，其实后面光储关就必须要这样做了，至少要2套，一套充一套放。
那这样投资者那个效益？
没有，他案子一定要大案子超过2串以上，2台 PCS 以上就是某种规模，对啊。所以我们要光储案或者风储案，其实就必须这样设计了。
那他刚才最后的回答，
之前在加拿大或是澳洲的太阳能的案子，它也是的 PCS 分两个部分，一个充一个放。加拿大的那个茶壁是湖的茶壁那个
有写吗？
那个是光储案嘛？
对，
原住民，所以也应该一充一放嘛，是不是也是这样设计？澳洲的也是光储嘛？
刚才那个，
如果它不是那个 online， 它是那 offline 的话，就可以切来切去。
不是，你在并电网，那是并电网不能 offline， 就是 online 的。对，所以是不是也就是这样设计？
可是他最后的回答，最后那句的回答是说 ，depend on 不同的 PCS 功能，譬如说他们有在用 SMA 嘛，在澳洲，它有 DC couple， 他回答是说 DC couple 可以直接对 DC充放电，但是他后面这个回答跟我们讲的是不一样的。
如果我搭配 DC couple 在风力发电或在是太阳能，那我是不是同时充放只要一台 PCS？ 那如果说 PCS 没有这个功能，我是不是要2台 PCS？
对，我们一开始是讲2套。
对，
充放电电压不一样。
DC 的话是
电电压不一样。充电电压
这样回答一下，
充电电压比较高。
Hello, Michael。
是怎样的电压不一样？
没看，他回答。
Hello。
麦克问没关掉。
Hi, Roger. Yep.
Okay, so one more question. Is my question now is when we look at this chart, charging discharging almost at the same time period. And then you mentioned it should be designed by two systems, two streams, different streams. However, is there any PCS which has a DC couple function, like you mentioned, the SMA products? Can we do the charge discharge in the same PCS equipment, or it should be?
I believe you can, but I would need to confirm with someone like SMA. I'm not a power electronics expert, so I would need to confirm with SMA or Delta or somebody, whoever you're intending to use. We would need to we just need to verify that was possible.
Okay, so because as of now, as your explanation, basically we need to design different stream connected to different PCS, which we can achieve the charge and discharge at the same time. Right?
Yeah.
Okay.
Yeah, and again, it's important to understand that this is an example of the use of the battery. There will always be constraints from the PCS interface in terms of this is what you can do with the battery, but depending on the PCS, there may be constraints about how much of this can be achieved, and we may need to look at different ways to enable the charge and discharge cycles, depending on the application and the PCS.
Okay. So as for the question, please help to double check with SMA. Okay. Continue.
Again, front of meter applications I've showed these before, so I don't need to really fly through them. But we have these type of applications in the market. Behind the meter applications, we've done work with industrial sites like water treatment plants, where it's a pure reduction of site electricity costs. In the case of the Equans project, it's maximising their use of solar power. And then Saboba Fire Station, this is a resilience project. It's bringing 10 hours of storage duration to a fire station in a wildfire area in California, who quite often have blackouts due to fires in the region. So again, multiple applications, multiple projects. They all have one thing in common, which is they are either looking at long duration, multiple cycles. They are high throughput applications, not your typical lithium battery, short duration, rapid energy dump type of play. Last bit is pretty simple, which is, again, stemming back to what I've been talking about, is not all opportunities would be ideally suited to VFB technology. We, through doing what we have done in the markets around the world, have found that it is really, really important for us to qualify each opportunity to make sure that we're giving ourselves the highest chances of success in selling our battery into a given project. We've spent a lot of time working with developers who, in the end of the day, really didn't have the right project for us. And so there are a few simple questions that we can ask to make sure that we're focusing on the correct application for our battery, and therefore giving us the highest opportunity for sale. And that is, what is the use case, the application of the project? Is it a behind the meter project looking at peak energy offset resilience? Is it a front of meter project where it's arbitrage grid services? Is it a microgrid project? Just what is the application? The critical business drivers, what's most important? Again, in Australia, most of the developers will turn around and say CapEx. We'll say, well, if CapEx is the only thing driving your project, why are you looking for a vanadium flow battery? Why aren't you doing lithium? So then you get to talk to them a little bit further, and they start to say, well, CapEx is important, but we also need an asset that's going to last 25 years, or we also want to have low operational and maintenance costs. So really important to understand what is going to drive the financial decision making in making a project go ahead. Again, we've spent a lot of time dealing with clients that in the end of the day really didn't have the budget to do what they wanted to do with a flow battery, and therefore reverted back to a low-cost lithium solution as a short-term fix. Capabilities and configuration to deliver this project. Again, this circles back to looking at what sort of duration do you want? Oh, I only need a 1 hour battery. Go and buy lithium. I want an 8 hour battery. Right, let's talk. Cycles per day, or flexibility in cycling. Power versus energy. If it's a high power application, so more in the grid services market is the only service, or they require very short bursts of high power because of very short-term demand, then maybe it's a lithium battery is more applicable. If they want kilowatt hours into their network or kilowatt hours into their site, well then a vanadium flow battery is the application. Again, it's all about high throughput via duration and or cycling. Really important to understand if there's market incentives, grant funding to support the project. We have a business development team that can help with submissions and so forth to these type of grant funds. Most of the markets around the world have some form of incentives, and if it can help reduce the capex and provide an opportunity for a battery to be deployed, we're certainly interested in supporting that. We find we are very, very successful at accessing incentive and grant money around the world to make sure that we get projects off the ground. And for example, the Spencer Energy project in Australia was supported by an Australian government body called ARENA, who provided a grant to the developer to offset around about 25% of the costs of the battery. Site-related restrictions and limitations. Again, really, really important to understand, are there any environmental restrictions that might mean our battery is a better solution to the client? Space limitations. Obviously, we do not have the energy density that a lithium battery has, and therefore, if they have a particular power or energy requirement, but they are limited by space, we may not be able to achieve all of the outcomes that they are looking for. Development restrictions around noise, site, the visibility of the site and so forth. If there are heritage overlays, for example, in Australia, we have to do Indigenous heritage assessments on all sites to ensure that we're not interfering with traditional sites for our Indigenous population. All of these things are really, really important so that we can understand, again, whether we're the right battery for the application. Stepping back to the earlier questions, is the project AC/DC coupled? Do you have a PCS in mind? EMS suppliers, are there any specific technical requirements? Do you require is your PCS grid forming, grid following? Is there certain modelling requirements? What are the data and data security needs? All these sort of questions are really important and will help us make sure that, first of all, that the PCS being selected is compatible with our product. And that if the EMS provider hasn't worked with us before, that we can commence an onboarding and integration process to ensure that the EMS is operational with our battery management system. And the last question, again, because we always want to know when the money is coming, is what stage is the project currently at? Have you commenced grid and development application processes? Is finance secured? What's the timeline for delivery and commissioning? We've found that if we ask these series of questions in a first instance with a customer, we can identify very, very quickly whether we need to go to the next stage of working on technical support, system design and building a proposal or an offer, or whether we step away from the project and as it being unlikely to be a vanadium flow battery application. That's it for session 1. Are there any other questions?
Hold on, please.
And
That's the whole
yeah.
I wanted to ask related with Mistral model. What is the status of Mistral model right now?
What is the status? What's the status of Mistral?
Yeah.
At the moment, we are constructing the beta model. So we've had the alpha test unit in operation since late last year, and that's where we're doing all of the things like our round trip efficiency testing and so forth. The beta model, which is our hand-built production prototype, is under construction. I believe that will be completed sometime in July, and then that will go into the testing phases as well. So I haven't had a full update as yet, but my understanding is that we are progressing steadily without any major hurdles, and all the tests that have been conducted around the stack, the new stack configuration and so forth have been exceedingly positive, and if anything, outperforming expectations.
Okay, thank you. My second question is that, as we all know, one of the limitations of vanadium flow battery is energy density compared to with ion battery. So the energy density is low. Now the new model, Mistral, is better energy density compared to VS3. So is the new model improves the energy density or similar to VS3?
It's similar to VS3. However, unlike VS3, and we'll talk about this more in the next presentation when we go into the technical training, but because we service Mistral through the front of the ends of the container rather than the sides, we can actually get more containers into a given space. So we can actually get more megawatt hours into a given location than what we can with VS3 because of the way that we have to space VS3. So that by rights improves our energy density on a system level rather than looking at it from an individual module perspective.
Because my question is just because the size is smaller compared to VS3 model, that means maybe the membrane may be thin compared to VS3 and so on. That means as an electrode also. So maybe the energy density little bit increase compared to VS3. That is why
there's more energy because there's more electrolyte. So there's actually more kilowatt hours in a Mistral than a VS3. So we're up to nearly 300. We're over 300 kilowatt hours rather than 230. But in terms of the power, the actual kilowatts, they're about the same.
Okay, thank you so much.
There are less. Mistral will have lower parasitic loads than what VS3 does because you've got less pumps, you've got less fans, haven't got a DC-DC converter built in. So the parasitic loads are less, which helps boost the round trip efficiency. But the actual power out is about the same because we're using exactly the same stack for VS3 as we are for Mistral.
Okay, thank you so much for your nice explanation.
That's okay.
Okay, Michael, seems there's no question now. So thank you very much for your teaching and speaking.
No problems at all. No problems at all. Thanks, Roger. If anybody has any questions, I will prepare this slide deck and send it to you, Roger, so you can distribute it to your team.
Yes.
If anybody has any questions following up, please feel free to email me. I'm happy to answer any questions as they come up.
Okay, thank you very much.
But thank you, everybody. Really appreciate you taking the time.
Thank you for your time today. Okay.
No worries at all. Thanks, Roger.
Thank you. See you.
Thanks all. Bye bye.
Bye.
我还没有 yes。
第一次。